biodiesel production is the process of producing the biofuel, biodiesel, through the chemical reactions transesterification and esterification. This involves vegetable or animal fats and oils being reacted with short-chain alcohols. Process steps. The major steps required to synthesize biodiesel are as follows. Feedstock pretreatment common feedstock used in biodiesel production include yellow grease, virgin vegetable oil, and tallow. Recycled oil is processed to remove impurities from cooking, storage, and handling, such as dirt, charred food, and water. Virgin oils are refined, but not to a food-grade level. Degumming to remove phospholipids and other plant matter is common, though refinement processes vary. Regardless of the feedstock, water is removed as its presence during base-catalyzed transesterification causes the triglycerides to hydrolyze, giving salt to the fatty acids instead of producing biodiesel. Determination and treatment of free fatty acids. A sample of the cleaned feedstock oil is titrated with a standardized base solution in order to determine the concentration of free fatty acids present in the vegetable oil sample. These acids are then either esterified into biodiesel, esterified into glycerides, or removed, typically through neutralization. Reactions base-catalyzed transesterification reacts lipids with alcohol to produce biodiesel and an impure coproduct, glycerol. If the feedstock oil is used or has a high acid content, acid-catalyzed esterification can be used to react fatty acids with alcohol to produce biodiesel. Other methods, such as fixed-bed reactors, supercritical reactors, and ultrasonic reactors, forego or decrease the use of chemical catalysts. Product purification products of the reaction include not only biodiesel, but also byproducts, soap, glycerol, excess alcohol, and trace amounts of water. All of these byproducts must be removed to meet the standards, but the order of removal is process-dependent. The density of glycerol is greater than that of biodiesel, and this property difference is exploited to separate the bulk of the glycerol coproduct. Residual methanol is typically recovered by distillation and reused. Soaps can be removed or converted into acids. Residual water is also removed from the fuel. Reactions transesterification animal and plant fats and oils are composed of triglycerides, which are esters formed by the reactions of three free fatty acids in the tridric alcohol, glycerol. In the transesterification process, the added alcohol is deprotonated with a base to make it a stronger nucleophile. As can be seen, the reaction has no other inputs than the triglyceride and the alcohol. Under normal conditions, this reaction will proceed either exceedingly slowly or not at all, so heat, as well as catalysts are used to speed the reaction. It is important to note that the acid or base are not consumed by the transesterification reaction, thus they are not reactants, but catalysts. Common catalysts for transesterification include sodium hydroxide, potassium hydroxide, and sodium ethoxide. Almost all biodiesel is produced from virgin vegetable oils using the base-catalyzed technique as it is the most economical process for treating virgin vegetable oils, requiring only low temperatures and pressures and producing over 98% conversion yield. However, biodiesel produced from other sources or by other methods may require acid catalysis, which is much slower. Since it is the predominant method for commercial-scale production, only the base-catalyzed transesterification process will be described below. Triglycerides are reacted with an alcohol such as ethanol to give ethyl esters of fatty acids and glycerol. R1, R2, R3, alkyl group. The alcohol reacts with the fatty acids to form the monoalkyl ester and crude glycerol. The reaction between the biolipid and the alcohol is a reversible reaction, so excess alcohol must be added to ensure complete conversion. Base-Catalyzed Transesterification Mechanism The transesterification reaction is base-catalyzed. Any strong base capable of deprotonating the alcohol will do, but the sodium and potassium hydroxides are often chosen for their cost. The presence of water causes undesirable base hydrolysis, so the reaction must be kept dry. In the transesterification mechanism, The carbonyl carbon of the starting ester undergoes nucleophilic attack by the incoming alkoxide to give a tetrahedral intermediate, which either reverts to the starting material, or proceeds to the transesterified product. The various species exist in equilibrium, and the product distribution depends on the relative energies of the reactant and product. Production methods supercritical process an alternative, catalyst-free method for transesterification uses supercritical methanol at high temperatures and pressures in a continuous process. In the supercritical state, the oil and methanol are in a single phase, and reaction occurs spontaneously and rapidly. The process can tolerate water and the feedstock, free fatty acids are converted to methyl esters instead of soap, so a wide variety of feedstocks can be used. Also the catalyst removal step is eliminated. High temperatures and pressures are required, but energy costs of production are similar or less than catalytic production routes. Ultra and high shear inline and batch reactors ultra and high shear inline or batch reactors allow production of biodiesel continuously, semi-continuously, and in batch mode. This drastically reduces production time and increases production volume. The reaction takes place in the high energetic shear zone of the ultra and high shear mixer by reducing the droplet size of the immiscible liquids such as oil or fats and methanol. Therefore, the smaller the droplet size, the larger the surface area, the faster the catalyst can react. Ultrasonic reactor method In the ultrasonic reactor method, the ultrasonic waves cause the reaction mixture to produce and collapse bubbles constantly. This cavitation simultaneously provides the mixing and heating required to carry out the transesterification process. Thus, using an ultrasonic reactor for biodiesel production drastically reduces the reaction time, reaction temperatures, and energy input. Hence the process of transesterification can run in line rather than using the time-consuming batch processing. Industrial-scale ultrasonic devices allow for the industrial-scale processing of several thousand barrels per day. Base-Catalyzed method Large amounts of research have focused recently on the use of enzymes as a catalyst for the transesterification. Researchers have found that very good yields could be obtained from crude and used oils using lipases. The use of lipases makes the reaction less sensitive to high free fatty acid content, which is a problem with the standard biodiesel process. One problem with the lipase reaction is that methanol cannot be used because it inactivates the lipase catalyst after one batch. However, if methyl acetate is used instead of methanol, the lipase is not inactivated and can be used for several batches, making the lipase system much more cost-effective. Volatile fatty acids from anaerobic digestion of waste streams Lipids have been drawing considerable attention as a substrate for biodiesel production owing to its sustainability, non-toxicity and energy-efficient properties. However, due to cost reasons, attention must be focused on the non-edible sources of lipids, in particular oleaginous microorganisms. Such microbes have the ability to assimilate the carbon sources from a medium and convert the carbon into lipid storage materials. The lipids accumulated by these oleaginous cells can then be transesterified to form biodiesel. See also, dehuling, vegetable oil fuel. References. Further reading, Gerpen, J.V., Biodiesel Processing and Production, Fuel Processing Technology, 2005, 86, 1097/1107. doi, 10.1016/J-Fupric. 2004.11.005, Ma, F. and Hanna, M.A., Biodiesel Production, A Review, Bioresource Technology, 1999, 70, 1 €15 doi, 10.1016 per second 0960-8524, 99, 00025-5. External links, Fast transesterification of soybean oil using ultrasonication, current state of ultrasonic processing for fast biodiesel production, biodiesel production technology August 2002 January 2004, UNL Chemical and Biomolecular Engineering Research and Publications, continuous process for the conversion of vegetable oils into methyl esters of fatty acids, biodiesel safety and best management practices for small-scale non-commercial use and production.